the full guide. I'm going to get rid of my annotation. So at the very least, what we want to be able to do at the end of this workshop is to be able to export a map. And so section 1.5 at the tutorial document spells out where we are and where we'll for sure hit. So you're generally close to target if you see the orthomosaic with some contour lines, and you're even in even better shape if you're actually seeing your contour labels. To export maps from QGIS, you use something called the print view, which is almost like a self-contained Adobe sort of Photoshop Illustrator type program. It really has a lot of functionality. You start by, and actually I realized something, is QGIS is prone to crashes like any other document. If you have not done Control-S to save your project now. Oh yeah, yeah. It's like Control-S or Apple-S as may work for you. Important step. Also, before we move on, you notice that our contours layer that we saved is actually just in memory. That's not written to file yet. To save this to file, right-click your contours layer, go to Export, and then Save Features As. This will bring up the Save Vector File Layer As. And because QGIS is not Esri, it doesn't make you save a shapefile first. You can go to your file format here and choose a shapefile if you desire that torture, or you can choose any other type of file format. Let's use GeoJSONs. And then promoting good file saving practices, keeping raw data and derived data separately. You can go to Browse and save this layer as a vectors derived layer. And if I were you, I would actually save it as contours_20 meter so that you can have a reference for what the contour interval is of the file. Sometimes as you're working with DTMs, you may have reason to have smaller or larger contours depending on how you're displaying your file. And in this way, you just add it that way. You also could put your style file if you want to save the way that you've mapped out your colors and your labels to your vectors. You could go and save that in the same folder. So go ahead and save those layers before proceeding, and raise your hand once you're there. Okay, hands are raised. So hands are raised, that means you're saved in a purely secular computer file form. I'm definitely not saved in other forms. All right. So once your project is saved, let's explore the print view and export ourselves a map. Go Project and New Print Layout, and name your print layout something descriptive. I might call it something like Trout Club, since the name of the community is Trout Club. Ask me about that afterwards if you want to know why. It's kind of a goofy story. Trout Club orthophoto with contours. And I might even say DTM contours. In this case, don't worry about leaving spaces because this is not really a file that you're loading. This then brings up a blank map canvas. And here is where basically a whole new world unto itself loads in. Before we take a step further, I think I might recommend we do kind of a 30, 45 second moment of silence where you look at figure 1.9 and just appreciate that this is a complicated menu. And I think if we take a moment to locate where all the icons are to add different tasks, things will go a little smoother. So scroll yourselves over to page 15 of the workshop guide for this. I'm gonna get some water. So QGIS does a fairly good job putting the main functions forward. The iconography is always tough. So the first thing let's do is let's add a map. And the add map icon, you can see is, oh gosh, 1, 2, 3, 4, 5, 6 down. 1, 2, 3, 4, 5, 6. No, excuse me, it's 7 down. Is that 7 or 6? 1, 2, 3, 4, 5, 6. It's 7 down. Okay. Thanks, QGIS, for testing our eyes. You can hover over it, and if it says add map, that's the one you want. Once you click add map, you can draw a rectangle occupying most of the canvas. Depends on your version. Actually, confession, I realized that I wrote this on my field computer, which I upgraded to 3.22. I'm actually working in 3.16. So my bad. Trust the guide. The guide is written with 3.22. That explains why some things look a little different. So you've succeeded now if you've drawn your window here. And this is just exactly what your map canvas window looks like. And in the guide, I think I had a suggestion for what to set your scale as. Set your scale as 1 to 2500. And any item you add to the map canvas will show up in sort of a layer tree under the items menu on the upper right, and its properties will show up down here. So go to scale and type in 2500. Scale should be if you add your map, and then be sure that map is clicked in the items bar, and then mosey on down to scale and type in 2500. And you notice that gets most of the project area in, but there's still this little pesky little corner that's cut off. So how do we deal with that? Well, you can reposition what's in the map content by this window, which is move item content. For me, that's the 4th one down. And so you can drag this menu down just a little bit to add those finishing touches. And you can see that now we have the flat edge in and the flat edge in. And if we want to add a scale bar and a north arrow, what we can do is basically add those functions to the map as they're indicated on the right. So I'm going to add a scale bar. And I'm going to add a north arrow. And as soon as you add them, you can then click on each one and drag it around wherever your cartographic sense guides you to drag it. Make mine a little smaller. Right? And now if I say, oh, shoot, I meant to futz with something else on the, and there are many things to futz with. Again, you can go to your items window, click on your scale bar that you just added, and then look for scroll bars that are not very well highlighted from the other menu, but you can see how you can change the delineation of units. Actually, funny enough, even though our CRS is in meters, but this does allow you to say change that to feet or yards for playing football, American football that is, or whatever. So I would encourage you to check out QGIS help for more detail on modifying print layout options. All that information is chaseable down there. And so the last thing that we would need to do is, in this case, add a title and explanations. So we can add labels to our maps with the little function that has little T on it. I know that doesn't really, it's hard to see on the screen here. Maybe you can shows up as a T better on yours. And you can add a title label. And if we're being real faithful to the exercise, you could copy what I had in section 1.5. I'm going to ad lib. You can double click the text and change its color. For now, let's just leave it all as defaults. We can align it to the middle. We can horizontally align it center, and we can say something like Trout Club orthophoto, and I can tell you this was April 28th when this imagery was collected. And so you can make your title whatever you like. And this is a very simple map. We don't have necessarily full contours or full items to really make as a legend. But what I would recommend in this case would be to make another label. Oops, I added an arrow, excuse me. We can make another text label and simply spell this out and say something like contours are elevation in meters above sea level. And you notice how that text is added in fairly straightforward fashion. And these elements can be adjusted ad nauseum to your desire. When you eventually want to save your print layout and export your map, there's a separate save function for the print layout. So when you hit Control S in print layout, that's saving the print layout. That's not saving your overall project. Do hit Control S now to save your print layout first. And then to export your map, go to Layout, and then you can either export it as an image, export it as a PDF, however you like. If we try, and both options are detailed in the guide. My favorite thing about the way this exports PDFs is you can very easily make it a georeferenced PDF such that you can pull it up on Avenza or your field mapping app of choice and have it be ready to go to geolocate where you are on the map. So I would save this in the output folder as opposed to the data folder because this is an output product. And here I would make the file name Trout Club and something like orthophoto contours date or something like this. When you go save it, you get PDF export options. And if you want to create a geospatial PDF, just click the geospatial PDF and then save. And then if you want to check to see that this is reduced, let me put it in my class folder, go to your output folder, and voila, there you have it. I'm going to, there we go. If for some reason the data layer doesn't render on a certain zoom on a PDF, just try zooming in and out. So that in a nutshell is the process of loading in drone imagery, working with rasters and vectors, altering their display properties, and publishing a map you can go out and use.
What if you wanted to rotate this image for some reason, just to make it, you know, like there's something in it you'd rather have it oriented a certain way for vision purposes?
Great question.
That's part of that question too. Does the north arrow turn automatically, or do you have to? So once it recognize that, the north arrow will always point north.
Let's test it out. So let's go back to our project view. Now, find the rotation function down there. And this is a great question because sometimes, like if you're working at a project site, people might want to see like from the street up, like engineers often work that way. So notice as I click this rotation, like say I go up one, aha, this is how you rotate a map. Like let's say, for example, a road contractor wants to go from San Marcos Highway back, and sorry if anyone's getting motion sickness by doing this. I just rotated this 150 degrees. This is not a question I often get, actually. So this is great. Now, you can go back to your print layout view. And what I'd recommend doing, just so you save your first layout and preserve it, is click Layout, Duplicate. You can make a copy of this layout and then call it, you know, the same. I'm going to call it, I'm going to abbreviate TC Ortho contour 20 meter. And I'm going to call it, well, the street is California Highway 154. Street down or street back. Hit OK. Now, go and find the refresh view button on this format and click it. And if that worked as expected, this would flip orientations. However, if it doesn't, what you can do is click on your map and then hit refresh under your map properties. And if that doesn't work, well, what you can do is try deleting this map and adding the map back in as you see it on your screen. And I'm a little befuddled why that didn't work.
You have to like stage it first or something.
Let's try that. Let's save it in the project view first, and then go to our orthophoto copy and then rotate it. Well, you know what else I realized we can do is in the main properties on the map window here, type in 150 degrees here. There we go. Usually there's at least 2 or 3 ways to do the same thing. in GIS. Often if you rotate or do some type of function in your project view, the print layout view will reflect that if you hit refresh. And if it doesn't, search for that separate function in print view because it probably is here. So click this main properties. And then if we want to be sure that the scale bars all match, take your scale back to 2500. And you can also right click on this and say item properties and basically drag it to the back. Rendering. And so you can see that the other items that we added are still there. Another thing you can do is say, drag your items in your item view page up here, just like the layers. And this also puts your items in order. Almost all these menus, if you hover precisely over it, you get a little drag bar that expands. And so just drag your map to the bottom so that you could see all your same scale bars. So that's a good question. That was rotating the map. Now, we're coming close to time in the workshop here, but your fun doesn't have to stop with QGIS. There are two other sections, section 2 and section 3, that actually detail how you can work with a digital surface model from the drone, a digital terrain model from LiDAR data, combine both and make a canopy height model and do a cover analysis to quantify ladder fuels cover. And so because we're coming close to time, I think we would be a little ambitious to try pushing through both of these other sections, except to say that you can read more about them in sections 2 and 3. And things you'll discover along the way include searching and running more complicated functions in the processing toolbox. You'll discover the raster calculator, which is how you would calculate NDVI or any other layer that you might want to make from rasters. And a canopy height model, again, is basically subtracting a surface model from a terrain model. And they don't have to be from the same data set. However, if they are not, it's very important to precisely georeference in 3 dimensions these data sets. Doing so is practically a college class's week's worth of material, but it's important stuff. And this is all stuff that maybe Drone Deploy or some other folks might basically do for you and spit out an answer in a paid subscription service. But this is actually how you do it yourself in QA/QC and actually know the quality of your data firsthand. You also will see what raster reclassify operations are. These are really important, really practical. When you compute a canopy height model in raw form, you basically just get continuous data of ground normalized heights. So 0 up to, in this case, it's around 30 meters because there's a couple pretty tall pine trees in the project area. Raster reclassify allows you to bin those into relevant height categories. And so this is all in section 2. And I offer a schema for reclassification. And if you want to see what the result of that is, I can bring it up on screen for you. CHM. Then we can again make this a Sado color and say choose reds. And there's a specific scheme again that I suggest, but your CHM would look something like this, and then raster reclass would look like this. Well, I guess that is, I'm going to take that one away. Pay no attention to that one. I did not save some of these output products in my local computer because I was guessing we would do that. But when I upload a final version of this workshop, I can upload the answer set so that you can check what you work on yourself against the final set. And then I'll highlight in section 3 of the workshop, once you create a canopy height raster and reclassify it, you can then do spatial analysis with polygons and vectors and your classified height raster. And this is, I would say, the entry drug or the gateway into more advanced geospatial processing. And this is the information that people really want from maps. It's understanding what is vegetation cover or cover by height classes. And at least in the case of wildfire preparedness, in the region, in some of the regions where I live and work, trying to keep your ladder fuels down to a minimum cover is important, because when a wildfire comes through, if all it has to burn is surface fuels, unless there's very, very extreme wind conditions, that can significantly reduce the hazard of a surface fire turning into a crown fire. Crown fire being a fire where trees are torching and you're losing your overstory. So all that fun is in this tutorial, and don't feel bad that we didn't get through all of this. Really, I got on a tear making this for DroneCamp with the thinking that this was basically an excuse to pre-write curricula for courses that I'll teach in the future. To really go through all this information together is probably 3 college weeks, three college course weeks with maybe a lecture and a lab a piece. So already we've done basically a week's worth of lecture and lab just to export a map and explore both vector and raster data properties. So I invite you to dig into this to really see where you can analyze three-dimensional georeferenced drone imagery for an actionable data product. So thanks for attending, and for the foreseeable future, I can be found either at UCSB Earth Research Institute or as of August 1st at Utah State University in Logan, Utah, and I'll be going between these places. And I'm the landscape domain lead at the Santa Barbara Regional Wildfire Mitigation Program, and you can ask me about that work after hours if you're interested. So thanks much for your interest and attention. Thanks, remote folks.
That was excellent. That was so good. I only have one thing that's a bummer, is that coming into the session, the record wasn't set. So I didn't find that out until over halfway through, because I thought that was absolutely awesome. With that said, though, I think that in the maybe with Mark's permission, I might go through that same type of material again and just record it and put it up and play, and of course,
or we could work together, and I could make pretend I'm teaching other folks. I may also find other folks in communities I work with to actually record a lecture that way. So we can be in touch about that.
Yeah, that would be
Yeah.
great, because I thought that was really smoothly executed there and at a great pace. I have to share my screen, stop your share,
All right.
and I'm gonna share mine really quick.
Sounds good. Do you want the HDMI cable here?
No, you can just leave. Let's see. I'm good right there. We can just run it through your screen right now.
All right.
This is gonna go out to largely to all the virtual people. They're just gonna say tomorrow, we're gonna do a lot of case study type of presentations. We're gonna be looking at, let's see, where we got coastal monitoring. We have Tahoe research with UAS. We have some health and safety stuff in Jamaica that was really cool. After today, we've kind of got through the hump of like the mental heavy lifting. We got all the equipment, like all those questions there. We got to do the flying yesterday, so the regulations. Here we have the data processing, visualization, analysis day following today. Well, hopefully it's inspirational, a lot of neat talks, but also at the same time, I want to make sure we continue to have the opportunity to ask questions, get your questions answered. Tomorrow afternoon, we'll have breakout groups, because that is one of the key things that is difficult. And this is unfortunately might not work out for virtual people. They won't have access to the breakout groups because there'll just be too many in one area. But we can then have Q&A on the regulations, the equipment, flight planning, more data and management, analysis, processing, all those types of questions. We'll have each of us that have domain expertise, we can break off and go over that and then revisit some of the material that you still want to dive into a little bit deeper. So there's so yeah, that's what tomorrow's going to mostly be. It's going to be a really fun day with a lot of good information, I believe. We won't have the office hours from 1 to 2, so we'll actually have a full day there. Any questions or comments or requests, you name it? No, I will check on the chat, make sure that there's nothing here that jumps out at me. If I can find the chat. Let's see. Good. I don't see anything here. Yeah, that was a great presentation. I think
Well,
that was
thanks
the
for
takeaway here.
Yeah, thanks for having me, and thanks everybody for coming.
All right.